The runtime function reflects the number of steps that an algorithm performs measured in the input size. The runtime function is also called execution time function. When you're going to determine the runtime function of the following examples, you might get slightly different functions than I do. And that is okay as long as your functions have the same asymptotic behavior, since later on we will only care about the asymptotic behavior. So the runtime function is only an intermediate step to express the time complexity of an algorithm. Okay, here's an example of how we can derive a runtime function for a program segment. Notice that the input is an array with n elements. As we measure the number of steps in the input side, we use n to express the input size. Now let's count the number of steps. The for loop sets I to 0 in the beginning. This step is only done once. Each time before the loop body is executed, the comparison I less than n is evaluated. So the comparison is done n plus 1 times. Then at the end of the loop body, I is incremented by 1. That's done n times. The loop body is executed exactly n times. To get the runtime function, we add everything up and get that t of n is equal to 3n plus 2. Let's look at a second example. Notice that the input is a two-dimensional array with m times m elements. So the input size is m squared. Let's use another variable to express the input size, let's say s. So in this case, the input size is s, which in turn is equal to m squared. So in the end, you want to express the execution time function in s. But when we count the steps, it will be easier to count the steps in terms of m. Okay, let's look at the outermost for loop. In this case, again, I is set to 0, which is done exactly once. The comparison I less than m is done before the loop body is executed, so it's done again m plus 1 times. And then I is incremented m times. Now let's look at the loop body. The loop body is executed m times, so sum is set to 0 exactly m times. The inner for loop is also executed exactly m times. Now let's count for each individual execution of the for loop how many steps we need to perform. Then we need to multiply that number of steps with m, since the for loop is executed m times. J is set to 0 exactly once. The comparison j less than m is performed m plus 1 times. And then the increment j plus plus is performed m times. The loop body, sum plus equal to a at index ij, is done also m times. So if we add this all up, we get that t of s is equal to, well, 3 times m squared plus 5m plus 2. Now we want to express this value in terms of s. We know that s is equal to m squared, or in turn that means m is equal to the square root of s. So what we get then is that t of s is equal to 3s plus 5 times square root of s plus 2. So that is the final result here.